Hello viewers, in today's session we are going to discuss another important and conceptual problem from integrals involving mod function, right? So in this problem we are given that this integral is equal to 0.4 times beta raised to minus 1. That is, we are given the integral minus 1 to 2 e raised to minus beta times mod of x dx is equal to 0.4 times beta raised to minus 1, where beta is some real number, right? And we have to find out the value of beta. So here we are given a mod function here in the power of this exponential number, that is e raised to minus beta times mod of x. So let us see how we can solve this integral, and then we can equate these two quantities to get the value of beta. So let us first quickly see the definition of mod function. Now see, mod of p is defined like this. Mod of p is equal to positive p whenever p is greater than 0. Mod of p is equal to 0 whenever p is equal to 0. And mod of p is negative p whenever p is less than 0. Now here we have mod of x, right? So for mod of x we can write mod of x is equal to positive x when x is greater than 0. Mod of x is 0 whenever x is equal to 0, and mod of x is negative x when x is less than 0, right? And here we can call this integral as I. And see, here the limits of integration vary from minus 1 to 2. So if we take the real number line, then here we have 0, here we have minus 1, and here we have 2, right? And from this real number line we can see that all the values which lies between minus 1 and 0 are less than 0. So in this interval from minus 1 to 0, x is less than 0. And in this interval, that is from 0 to 2, x is greater than 0, right? So here mod of x is positive x when x is greater than 0. So when we go from 0 to 2, then x is greater than 0. And when we take mod of x is equal to negative x, it means x is less than 0. So we go from minus 1 to 0. So we can now split this integral I into two parts, right? So we can now write minus 1 to 0. The integrand is e raised to minus beta times mod of x dx. And then we have the limits from 0 to 2, and here we have e raised to minus beta times mod of x, and here we have dx, right? So when we go from minus 1 to 0, it means x is less than 0. So mod of x is now negative x. So we can now have minus 1 to 0 e raised to minus beta times minus x, and here we have dx. And when we go from 0 to 2, then mod of x is positive x, right? So we have here 0, here we have 2, and we have e raised to minus beta times positive x and dx. So now let us simplify. We have minus 1 to 0, and here we have e raised to simply beta x. Minus times minus is positive, and then we have 0 to 2 e raised to minus beta x and dx. So now here we have two simple integrals, and we can now write the integral of e raised to beta x as e raised to beta x divided by beta, and the limits of integration are from minus 1 to 0. And here the integral of e raised to minus beta x is e raised to minus beta x over minus beta, and limits of integration are from 0 to 2. Now let us take 1 over beta outside the integral, outside this expression. We have e raised to beta x minus 1 to 0, and here we can take minus 1 over beta and e raised to minus beta x, and limits of integration are from 0 to 2. So now substituting the limits and taking the difference, we have here x is equal to 0. So we have simply e raised to beta times 0, that is simply 0. And then we have x is equal to minus 1. So here we have e raised to minus beta. And here we have 2, x is equal to 2. So we have e raised to minus 2 beta, x is equal to 2, and when we take x is equal to 0, this term is 0. So we have simply e raised to 0. So now we can take 1 over beta common from these two expressions. So we have e raised to 0 minus e raised to minus beta, and then we have e raised to minus 2 beta minus e raised to 0. So now let us simplify it. We have 1 over beta and e raised to 0 is 1. So we have 1 minus e raised to minus beta. So we can write it as 1 over e raised to beta. And then here we have e raised to minus 2 times beta, which can be written as 1 over e raised to 2 beta minus e raised to 0 is 1, right? So we can now write 1 over beta and 1 minus 1 over e raised to beta minus 1 over e raised to 2 beta plus 1, right? So minus and minus times it becomes positive, right? So now the value of this integral I is given by this expression, and we are given that this integral is equal to 0.4 times beta raised to minus 1. So here we can write 0.4 times beta raised to minus 1. So this can be written as 4 over 10, and we can write here beta, because beta raised to minus 1 is 1 over beta, right? Now see, 1 over beta term is here, and here also we have 1 over beta. So this term and this term get cancelled. So now we have 1 plus 1 is equal to 2. Then we have minus 1 over e raised to beta minus 1 over e raised to 2 beta is equal to 4 over 10, right? And 4 over 10 can be written as 2 over 5. So here we have 2 over 5. So now let us solve this equation in beta by using this substitution, that is e raised to beta is equal to say y, right? So this expression is now 2 minus 1 over y, and here we have 1 over y square, because here we have e raised to 2 beta, and if we take the square of both sides, then e raised to 2 beta is equal to y square, and here we have 2 over 5. So let us simplify it by taking the LCM. Here we have y square, and then we have 2y square minus y minus 1, and here we have 2 over 5, right? So taking the cross multiplication, we have 5 times 2 10y square, then we have minus 5y minus 5, and here we have 2y square. So solving this quadratic equation, we have 10y square minus 2y square minus 5y minus 5 is equal to 0. So this is 8y square minus 5y minus 5 is equal to 0. So now we have this quadratic equation to solve, and we can easily solve this quadratic equation by a method of discriminant. So the value of y can be given by the quadratic formula, that is minus b plus minus square root of b square minus 4ac divided by 2a, right? And the value of a is 8, the value of b is minus 5, and value of c is also minus 5, right? So we have here b is equal to minus 5, so this becomes positive 5, and then the discriminant is b square minus 5 square is 25. Then we have minus 4 times a is 8 times c is minus 5, and in the denominator we have 2 times 8. So now we have 5 plus minus square root of 25. Then we have here minus and minus becomes positive, and 4 times 5 is 20, 20 times 8 is 160 divided by 16. So now this is equal to 5 plus minus square root of 185, and in the denominator we have 16, right? So now y has two values. One is corresponding to the positive sign, and the second one is corresponding to the negative sign. So now we can write the value of beta by using this value of y. So taking this value of y in this equation, we have y is equal to e raised to beta, right? Now taking the natural log of both sides, we have natural log of 5 plus minus square root of 185 over 16, and here we have natural log of e raised to beta, that is equal to beta times natural log of e, and natural log of e is 1, so this is equal to beta, right? So the value of beta is now a natural log of 5 plus minus square root of 185 over 16. So from here we have two values of beta, but here the condition is that beta must belong to the set of real numbers, right? So let us first analyze this expression. So now from here we have two values of beta. The first one is a natural log of 5 plus square root of 185 over 16, and the other one is log of 5 minus square root of 185 over 16, right? Now here this expression is always going to be a positive, right? And here we can see that the square root of 185 is greater than 5, right? Because here we have 5 minus square root of 185, and obviously the square root of 185 is greater than 5, right? So this difference, that is 5 minus square root of 185, is less than 0, that is this expression is negative, right? So here we have the natural log of negative quantity, right? And the natural log of negative quantities are not defined in the set of real numbers, right? So for that we require the set of complex numbers. So here beta it should belong to the set of real numbers. So we have to discard this value of beta, that is we have to discard the negative sign here, and we have to accept only the positive sign, right? So the required value of beta is now given by a natural log of 5 plus square root of 185 over 16. So viewers, this is how we can solve this problem. And remember here, beta must belong to the set of real numbers, and here this quantity is negative, and the natural log of negative quantities is not defined in the set of real numbers.